printing, you can hear 100% infill. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm tube. Whoa. Be mine. All our different materials. How do you guys like it? I think we are live. And we are. How's everyone? Non-fam, OneRaz, Rover, Matt German, Martin Draka. Hey, Matt Tyson, how are you? LS Out of Order. What do we have? Come out on PLA. How's everyone? Today we are not only streaming on YouTube. I'm trying the same. It should be also live on Facebook and on Twitter. I actually didn't know we could go live on Twitter. So then hopefully we're reaching a little bit more people in order to make sure that everyone has access to a way to answer their 3D printing question. Hi, Peslis. Lizzie Beth. Thank you for joining the Q&A, today's Q&A. So I hope. Oh, Peslis, are you watching from Twitter? Let me check. If it's working. So we should be live on Twitter. Yeah, there you go. And then we should be live on Facebook. Yeah, there you go. Perfect. Then I don't need to leave my Facebook open anymore. And then, as always, what is the best filament brand? Let me think about it, Zombie. That's a good question. I've tested a few of them, and there's that brand. What's the name again? A Chinese brand, Polymaker. I think it's Polymaker. Pretty good filament. They have a wide range of materials. Each material comes in a wide range of colors. You have access to good amount of information. If you go on their website, if I remember well, they just launched something like material comparison, and then you have access to some data. They have a pretty good community. If you have some issues, I think they have a Discord. There is some kind of giveaways. They support a lot their community. So yeah, you should check out that brand. For me, it's one of the best filament brand in my very unbiased opinion. Okay, so let's bring some awesomeness there, and then let me put the banner so that if people join during the stream, then they know how to be awesome again. Okay, so like always, please ask all of your questions in the chat, and then we'll go through some of the question on Reddit. As always, it's crazy the amount of issues that people has. I mean. You see 17. Oh, let me just refresh. I mean, we have questions almost 1 minute ago. Almost every minute we have questions. Look at all of these 3D printing questions. So we have a lot to go. We have a lot to go through. But let's start with the few questions that you may have. So where was I? What is the best filament brand there? Jesse PLA, yeah, Jesse PLA is very good. 3D X-Tech, yes. If you are into engineering materials, they have a very nice range of glass fiber nylon. That's one of the rare brand that is doing different colors in PS6 GF in nylon glass fiber reinforced. I don't know exactly what nylon they use, but they have some nice colors. Polydissolve S1 or poly support for Polyterra. Both are fine, Zolan. It depends on what you want. So the main difference is more one is dissolvable and one is breakaway, but both will work fine with Polyterra. I don't use Polymaker because they stopped sending stickers. Yeah, I heard that. I heard that they changed the packaging to a more eco-friendly one. So I think it was a good choice for them to to be more eco-friendly, responsible. A lot of awesome people just joined. Jenna, CR, S1. Thank you everyone for joining the Q&A. I hope you have a bunch of 3D printing questions so that we can answer them for you. But of course, we can also answer some of the other on other channels. So we have, like I said at the beginning of the stream, we have Twitter, Facebook, and YouTube together today. I want to try to see if we can reach a little bit more people with this Q&A. Have you heard of the Positron 3D printer, Thibaut Ware? Yeah, of course. We made a full stream on this printer on Twitch. An awesome printer full of innovation. I really like that printer. It was suggested from Bear, one of the community member. Really nice printer. The best part of that printer is all the small innovation, all the challenge that he has encountered, and the small innovation that he had to put together in order to solve all of these challenges. Polymaker, talk about Prime Day deals. You have a few hours left. Polymaker, talk about Prime Day deals. You have a few hours left. I don't think there's a few hours left. I think it's 2 days. It's the 12th and the 13th. I mean, in the US time. So I think Prime Day is 2 days. So you should have a few hours plus another full day. Love the new packaging. By the way, the carbo spool are great. Thank you very much for the feedback. We did spend a lot of time designing, well, first sourcing the best material because we wanted a recycled cardboard, and it's very hard to always find consistent supply chain of recycled stuff. So we actually bought a lot of carbo spool and from different companies, and then we compared the different ways of doing carbo spool. And most of the carbo spool at that time on the market was corrugated cardboard, but we thought it was too weak, so we had to design a new type. Will new colors ever come to Polymax PLA? Yeah, 2 new colors that are already on the way. I'm not sure where you are based, Thibaut Ware, but if you are based in the US, we have 2 new colors coming for Polymax PLA. They should be released. In 3 or 4 weeks. Hi, Quideng. Thank you for being awesome. Michael Wingington, thank you for joining as well. Zombie, I may or may not build one when it comes out as a kit. Yes. One for you, one for me. Don't forget, Zombie. CRS1, I never got the raw TDS data, so I extracted from about 20 PDF and noticed that most filaments don't have Sharpie impact strengths for Z. Is it due to printability? CRS1, you should not need to do that anymore. So if you go, let me share that with you. I'm not sure if you know about it, but if you go on our website, you don't have to extract from the PDF anymore. So if you go here, material comparison, if you click there, you're going to be redirected to a database. And then here you should have everything. So you're talking about the Sharpie impact strength on the Z-axis. So yeah, indeed, we only have ABS, ASA, and Polymax PTG for this one, mainly because the Z-axis is on our new standard. So we haven't done all the material yet. So it's from the 2022 standard. So almost every year, not every year, but almost every year, we have new standards for our TDS. That's why there is different version. And then we need to retest all the materials. So we do have them in-house. I need to upload it on the website, but we still don't have all the materials. But we have most of them. I just need to update the website. But CRS1, normally you don't have to do that anymore. So before, yes, people had to download all the PDF and compare them to each other. But now you have access to this tool, which should allow you to not do that, not do this this work, because it's very time consuming to extract all the PDF, to export, to download all the PDF. It's not due to printability. You can some of them, for example, what? Let me think. Maybe no, not even Polywood. Yeah, none of the material we have released, but we did have we did have some formula that it was so weak in the layer adhesion that we couldn't even test, because it would break directly. But out of out of the one that we have released, they all have Sharpie impact strengths on the z-axis. Blah blah. What filament dryer do you recommend? We recommend the one we are going to have soon, but except from that, right now on the market there is two that I like. The first one from I think a company called Print Dry. I think they've been doing that. It's very simple, it's very straightforward, and I think it's very cost effective, and it's working. It's based on food dehydrator, but I think they just remixed it for 3D printing. I think it's pretty nice. And the other one is called A-Bus, I think. Let me check. Do they have a website? Amos 3D dryer. Yeah, maybe this one. So this dryer pro, maybe. I haven't followed. Yeah, that one. So that one is working pretty well. It's very straightforward. It's like I said, based on food dehydrator, and it's working pretty well. I like this company. I think they are doing it. They're designing their product well, not over design, and the functionality is there. And this one I like it, not because it looks like the Polybox, but mainly because of the drying technology they use compared to other box like the E-Box or the Sunlu box, even the S2. I don't really like the drying technology. What they use is they use a heated pad, if I remember well, and this one use a blow dryer. And from a polymer perspective, I believe that blow dryer are more effective than the heated pad with a fan. So that's what I would recommend. Matt Tyson, will there be a large pool of Polymaker PA sometime soon? Yeah, funny that you asked this, because we literally talked about it yesterday during our team meeting. And yes, we plan to have a 2 kg Polymaker PA black. We don't have a timeline yet, because it was literally yesterday that we talked about it. But yeah, that's in the plan. I want to make a solid cube like you did. 750 grams is not even close enough for me to do a cube like yours. Yeah, we will have them. I don't remember how I printed that cube. Did I change, or because our samples from R&D are always 1 kg, not 750 grams. Maybe I use one of these samples, or maybe you are going to print the cube in a bigger printer that I printed it, because I think I printed that Polymaker PA cube on a Ultimaker 2 Plus extended, if I remember well. But yeah, that's in the plan. Hi Incendium, thank you for joining. I need some Amazon Canada deals. We should have. You can check. You can check in Amazon Canada. We have less deal than in the US, but they should be around 200 SKUs that have deals. Most of them are 2.85. But I think some Silk 1.75, Polysmooth, Polymax PLA, I think all of them have the Amazon Prime deal. Would you supply spools to other companies so they can also be more green? Yeah, we also offer white label as well. So, and most of our white label really like the fact that we are now offering cardboard spool as an option. Mark and Draka, make sure to check out the Prime Day Polymaker sale. Yeah, we do have I mean, I guess you already know, but if you go on our Amazon store, we do have very interesting deals for the next 2 days for Amazon Prime. I extracted manually because I want to try different visualization. Oh, okay. I think, let me check. Did I allow the, let me check. So I'm not sure, but you could extract the raw data from here, but I don't remember if I allowed that or not. Let me check. No, maybe I did not. No, maybe I did not. Okay. It was a couple of hours to strip the data and normalize the data. Yeah. Well, hopefully that's why I created this one. I'm working on different visualization. If you have some ideas, CRS1 on what type of visualization you would need, then you can let me know. I can just add some graph here, and it can be useful for other people. Nice. Looks like some people are taking advantage of the different deals. Oh, sorry, I was not sharing the screen. So CRS one, I was talking about this here. So if you have some ideas on nice graph or infographics that could be useful for people, then you can let me know, and then I can plot all the graph here. Okay, so I think that was the question. If you have any other 3D printing question, feel free to post it in the chat. And meanwhile, we're going to try to help some of the people in the 3D printing community on Reddit. It's quite crazy. Do you know that there are 1.5 million now? 1.5 million members. It's growing faster and faster. It's crazy the amount of people that are in 3D printing nowadays. Hey, local maker MI, sorry. Thank you for joining the Q&A. Let me know if you have any 3D printing question. So the first question, new to 3D printing, can you guys give me ballpark cost to do this? Okay, not really a troubleshoot issue. Can someone send a link for PS4 controller trigger STL or something? I couldn't find one. I know there has to be one. Okay, there's a lot of libraries. I don't know what's your favorite libraries. It looks like printables. It's becoming more and more popular. I think Thingiverse still have the largest libraries of STL. And by the way, did you guys know I just saw an ad on Facebook about this STL Flix, and I don't know if you knew about that, but that's very new to me. That's so I don't know if I can find back that advertisement that they put together, but it was a Facebook advertisement, and they say so their marketing is they are the Netflix of STL. So I don't think I can find the advertisement I've seen, but basically that's this. So it's like Netflix. It's a subscription based, and you have access to a bunch of STL. So I don't know if they work with designers, and then designers have some kind of royalty or something like this. I don't know how it works, but it's interesting. It's interesting how the STL library market is evolving. So you have you have that free download way, and then you have exclusive Discord server, blah, blah, 3D printing pictures, blah, blah. So it would be interesting. I mean, how much are we talking about? We're talking about $10 a month, weekly new STL drops, access to STL Flix full library while a member, access to STL Flix Discord exclusive server, early access to 3D new file. So again, I don't know how they do that. I don't know if they have a bunch of designers or I don't know. I don't know what's their model, but I discovered that literally I think today when I browsed Facebook, then I saw their ad. So I'm not sure how many of you have heard about them, but I thought it was interesting. Any plans for 250-gram spools, like a sample pack, pick 3 colors at the price of 750-gram spool? Thibaut Ware, yes, we have planned to have it's not going to be 250 gram. It will most likely be 500 gram, and it will be basically a carton, and then you will have a bunch of Polytera PLA colors inside, but in half spool. So you will be able to buy, for the price of one, you will be able to buy two colors. So like instead of $20 for one color, it's $20 for two colors, half. So we had this idea from the community. I don't know if we are going to go lower in the amount of spool, but we will have a new way of selling our materials. So, we had plastic spool, we have cardboard spool, and then we are soon going to release a new way of new packaging. Kong Dabom, are you the Kong that are you the amazing designer, the one that designed our Polymaker scientist? I think so, from the profile picture. I'm running out of Polymaker PLA, so this sales is amazing. Again, Kong, if you need some PLA or something, you can let me know. I can send you one or two spools. That's not a problem. So for those that don't know Kong, if it's the right Kong, is a designer. So the material scientist that we have, that is one of our kind of mascot, it was designed by this designer. Zombie, Thingiverse is still the best database, but I use Thanks to cross-reference everything. Yeah, I do exactly the same, Zombie. Thanks has a much better search engine, and they search in Thingiverse. So Thingiverse has the database, and Thanks has the tool to search the database. Mark you, thank you for joining. LS out of order. Saw the ad for the STL fix as well. Oh, okay. Seems interesting, but don't know that I would actually print what they are marketing towards. Yeah, actually, when you check their main page, STL Flix, it seems to be more towards SLA or DLP, right? I mean, when you see, of course, they are going to put very impressive model, but this type of model, I don't know if it matched very well for FDM. Maybe a little bit more this kind here. And then this one is the same. Look at the amount of details. I think that's more for resin printer, liquid resin printer, more than FDM. What is your favorite STL file that you didn't make yourself, non-Polymaker design? What is my favorite STL file? I think the car jack. That's the one of my very, very first fun 3D printing project, and I don't even know if YouTube still have that video. So 3D printed car jack, Polymaker. Oh yeah, still have the video. So that's my favorite STL. Why? Because first, because it was one of my first 3D printed project. Fun 3D printing project. And second, because I really like, what I like about that design is how to, you think about a car jack that is made out of metal, and then you have to rethink everything because it's not going to be made of metal. So, there's a lot of thinking that goes into making a car jack that will be 3D printed. And I like all the STLs that are, redesigning a tool that we are already using, but thinking that is going to be processed, is going to be made with 3D printing. So I really like that model, and not because it comes from you guys, right? Just because I really like that model. I like the functionality. I like the fact that it's functional. Like it does the job. I wouldn't recommend it having, definitely not recommend to have that to replace the real car jack, but it was a very fun project. Zombie, oh yeah, I'm like out of all my normal colored PLA, need a bunch of PLA Pro. Yeah, Zombie, by the way, we have a bunch of new colors coming. So I think nobody will be able to have all the Polymaker colors. You guys don't have enough space in your in your shelf to have all the new colors we are going to launch. Polylight for the Death Racer. Yeah, I think I answered you, the local maker. I answered you on Twitter. I haven't checked if you answered back. But I just asked whether you're going to use the Polymaker design. There is a special Polymaker Death Racer for all the people that we are sponsoring them. Genia, on a previous stream, you said Eason ABS is cheating. Did I say they're cheating? Is it because of their glass resistant temperature is being 73, their Polymaker ABS 100-ish, ASA 95-ish? Well, I'm not sure I say they're cheating, but what I said is important to know what's the difference between ABS and ABS Plus. And then we did some research, and we found out that the HDT of ABS Plus was 73 degrees Celsius. So which means the TG is most likely around 73. So I guess what I said is important to understand that ABS Plus is more like a PDG in terms of heat resistance compared to a more traditional regular ABS that is more around 100 degree. I guess that's what I meant. Does that mean Eason ABS Plus will start softening at 73 degrees C? Yeah. I'm not sure if I can find back the TDS. Maybe I can, because I think it was sent from someone. Let me check. Maybe we can find it quickly. ABS Plus, download, TDS, and then for tensor flexural thermal property. You see, so you have the HDT here, heat distortion temperature, and then it's 73 degree. So the HDT for amorphous material should be pretty much the TG. I mean, if you look at, if you go and check our Polylight ABS, and then you go and check the HDT, you see it's exactly 100 degree. And then you go and check the glass resistant temperature is 101 degree. So even if you take the HDT at 1.8 megapascal, then it's 98. Why? Because it's pretty sharp between the rubber state and the glassy state. So the HDT, whatever the stress, I mean, to a certain extent, will more or less be the glass resistant temperature. So when I saw that the ABS Plus was 73 degrees C, then it means their TG is very low, right? To around 73 degree. And then if you go and compare it with PTG, so for example, our Polylight PTG, you see the HDT of our Polylight PTG, even the HDT 1.8 is megapascal is 75. So even our PTG, the TG is 81. So even our PTG is more heat resistant than their ABS Plus. So that's what I highlighted, because a lot of people were talking about ABS Plus, and then I felt like the difference between ABS and ABS Plus was not clear in their mind. So that's why, you know, we did some research during one of the past stream. Yeah, so hopefully that answer your question. I ordered teal to keep it 100. I just ordered teal to keep it 100. Sorry, I don't understand. Come out and PLA. Yeah, I know. Waiting for new colors too. Hoping for a rubber duck yellow. Oh yes, you will have. I think it's going to be called lemon yellow. Because I mean, I still remember you highlighted this on the Discord. So we will definitely have a real yellow, not the yellow we have now that you are calling orange. We will have a yellow. FDAF patch. Hi Nick, in the Discord we have seen that you're busy lately. Wish you are doing okay. Yeah, like I said last time, you know, it's the half of the year, so there's a lot of things going on. You know, we have to review the first half of the year, and then we have to establish all our new strategy for the next half and stuff. I'm trying to stay up to date with the message, but I'm very late. But I will try to take some vacation from my real work in order to catch up with the community work, let's say. I don't really consider that as a work when it comes to the community, but I will definitely be a little bit more active. I apologize for that. Will you be at Earth this year in October? I would canvas your special materials that are incredibly strong. I hope I will be. We talked about this in last stream. I'm not sure yet, but I hope I will be. I will be at Earth, but I haven't discussed that with the team yet. Once I have an answer, I will definitely share with you. Okay, great. I take one to replace my orange yellow. Yeah, lemon yellow. I think it's gonna call if I remember one. I use my yellow for calibration because I don't like the color. Okay, so we just launched a color in order to make your draft print. Is that what you're saying? You're asking us to release a bad color for your draft print? That's an interesting recommendation, Zombie. Okay, next one. Under extrusion just before layer change. Okay, so what is that about? Under extrusion, I switched from BMG Bowden. So BMG, we checked that on the Twitch stream. By the way, if you are also very bad at hardware stuff in 3D printing, like all of these names that you have no idea where you come from, you should join our Twitch stream every Saturday. We are educating ourselves on all of that. So, for example, the BMG extruder, we learned what was this during that Twitch. So you cannot be worse than me in hardware. So definitely you are going to learn a lot of different stuff during that stream. So anyway, blah blah. And since I've been having issue with the nozzle skipping just before a layer change. Okay. And then my print looked pretty solid before switching over to direct drive. So I expect that's the culprit. Does anyone know what might be causing the issue? Okay, so it looks like when he's finishing the layers, then it's not you have that kind of under extrusion here. So do you guys have some ideas of what it could be? We had that issue before. You know, it could be the costing that is too big, but I doubt he hasn't thought about it yet already. So let me check what he reviewed already. Clipper with PA resonance compensation enable Eastern. Oh, there you go. Because he's not using Polymaker materials. Yeah, that's solved. No, I'm joking. 100 millimeter per second, outer wall 70. Try lowering this, no change. 2 millimeter retraction, 30 millimeter per second. Try messing this, no change. Okay, interesting. So what I would do for this, I don't have retract on layer change enable, and here are all my other settings. Okay, let me see if you guys have some ideas first. No, you already have it. Oh, you mean the yellow-orange is becoming your draft PLA. He needs to tune his retraction and E-step, possibly. Looks like he already played around with his retraction and no result, apparently. I'm not sure E-step will help because the rest of the print looks good. Let's see if you know this. Explain the new Revo CR to me. We haven't checked the Revo yet. We have a special hot end stream soon. I know what the Revo seems to be an easy system, to change your nozzle, and CR, I don't know, maybe the new Revo for Creality, I guess. Hi, Francis. It's usually too much retraction, I've heard. Yeah, again, it looks like he already tried changing his retraction without any success. We can't. Thank you, FDAF patch. Then how everyone can. You guys are awesome. You've been able to troubleshoot something that you're not even seeing. That's amazing. So let me show you. Now you have the picture. So it should be even better. White before retraction. 2 millimeter retraction seems high for direct drive. I got an answer on Discord, but curious your opinion. Different ASA color. Okay, let me answer that after. Share your screen. Yeah, sorry, we can't see the print. Sorry. Yes, Revo CR is for creativity, good work, one sticker, not a Polymaker one though. Yeah, so what do you guys think? For me, I don't have any answer. I would have to play around with it. I would have to disable completely the retraction, but again, it looks like he doesn't have the retraction on layer change enabled. So that means there is no retraction going on here. It could be something related because he's using Clipper. So my guess is because he's using a PA, I think he's referring to pressure advance. So my guess is that there is something wrong with his pressure advance. So it's not set properly. So it means it's extruding a little bit too much before, and then it doesn't have enough for before the end. It's a little bit strange because it means every end should have that issue. But what I would do in this case is I would go back to the basic, which means I would disable pressure advance. I would disable resonance compensation, even though I don't think this has to do. I don't know how it works, but I don't think it has to do. But I would disable retraction, disable pressure advance, disable resonance compensation, and then do the print again. And that's usually how I do. How I do to troubleshoot is I just disable as many things as possible. And if I still have the issue, then I know it's not retraction because there's no retraction. I know it's not this. I know it's not this. So when you still have the issue, it gives you a lot of information because it cannot be much because you disabled everything. And if you don't have the issue anymore, then you can just add back one by one, and then you will quickly figure out. It's not a long print. I mean, it might be 10 to 20 grams of material, and maybe depending on the printer you have, maybe a 5 to 10 minute sprint. So I think it's okay to do that kind of troubleshoot. But again, from that picture, from that amount of information, I don't know where what it could be. Clogged nozzle under extrusion. Yeah, I wouldn't think so because the rest of the print is good. If it would have been a clogged nozzle and under extrusion, you would have a more even issues rather than only at the layer change. He needs to tune pressure advance. Yeah, that's usually what it looks like when pressure advance is too high. Too much pressure advance looks exactly like this. Looks like too much pressure advance. Okay, so looks like we agree on that. So it seems to be related to pressure advance. So nobody answer him. So if nobody answer him, then check your pressure advance settings. Try to disable it. It should solve the problem. Then recalibrate your PA. Okay. So again, if we are able to troubleshoot something and there is no one that answered, then it's our duty to help that person. 3D printer is under, even if he's not using Polymaker product. 3D printer is under extruding and PLA is expanding in the tube. Ooh, that sounds like heat creep. Sounds like heat creep. What do you think? Yeah, it sounds like heat creep. So let's read that. Maybe he tuned pressure advance in the Bowden configuration and then changed the direct drive. He didn't lower it enough. Oh, that's a good point, FDAF patch, because he did change from Bowden to direct. So that's a good point. It could be. Yeah, that's a very good point. 3D printer is under extruding. PLA is expanding in the tube. Hello, I already posted in Fix My Print a few hours, but since I'm in a bit in a hurry, since I plan to print something for someone's birthday, which is soon, I decided to also post my Chroma Lab. For a while, I had issue where filament is expanding in my Iligu Neptune 2, which often result in under extrusion and skipping sound because the filament is blocking the path. So first thing, I know he's not using Polymaker filament because Polymaker filament has the jam-free technology, which should avoid that issue. I already checked the fan. If any of them might be damaged, as far as I can see, they are undamaged and working as they should. My printer setting is 55 on the bed. 195 on the nozzle. I use a skirt as a, who is using Fahrenheit for nozzle and bed temperature? Nobody, right? I use skirt as build plate adhesion, and the print speed is 50 millimeters per second. The only part of the printer I change is the beginning feeding gear from brass to steel. The rest is normal. If you guys need some more picture and further information, then of course feel free to ask. Yeah, I mean this is definitely something related to heat creep. I mean, his brim is not good, so definitely his nozzle is way too close to the bed. But it looks like it doesn't matter, because even after doing that first layer way too close to the bed, then it's printing fine, and then suddenly it stopped. So usually that means, something has built up here, and it looks like he has this issue all the time. So I don't think it's a clog, because if it's a clog, then if he restart the print, then he would have issue earlier. But it looks like he always have issue at the same height. So it means the temperature always build up to a point around that height where the filament will expand in the cold hand, and then we'll just jam the printer. So at this point, I would recommend two things. Either switch to a Polymaker PLA, because that's the only one with the jam-free technology, or change your hot end. I mean, is either there is a defect somewhere that makes the fan not cooling down the cold end very well, or what did I just say? So either it's a bad design, so just change the hot end. Either there is a defect somewhere in the hot end. Maybe you check the fan, so it looks like it's not the fan, but usually it's the fan. Usually the fan that is responsible of cooling down the cold end is not active, but it looks like in this case is active. So maybe it's just a bad design. But I know a lot of people printing with the Neptune 2, so it's strange that his Neptune 2 is not working well. So maybe just a damaged hot end that doesn't have a very good, or maybe let me see, maybe he didn't put the nozzle properly. Yeah, it's definitely heat creep. Where the heat creep come from, I'm not too sure, but I'm 80% sure that is because of heat creep. Yeah, heat creep was my first thought. How does jam-free technology work? Come out on PLA. Basically, we are crystallizing our PLA filament in order to have more heat resistance. So the heat resistance of the filament itself is 140 degrees C. But after you print it, then it becomes amorphous again. So the heat resistance is 60 degrees C. But the fact that the filament itself, the heat resistance is 140, which means it's much more stable in the hot end. Rather than the other PLA, the heat resistance is 60 degrees, which means when you're printing, it's very easy to jam. I mean, not very easy, but there is more chance to jam, because if the cold end reach 60 degrees, then it will start to soften, expand, and then jam your nozzle, jam your hot end. Maybe the PTFE tube is messed up on the hot end. Yeah, that's a good point. That's actually a very good point. So maybe let's just say this. It seems to be heat creep issue. Not sure where it could come from. Bad cold end cooling fan, or bad hot end design. It could be a damaged PTFE tube. I would suggest to replace it. Yeah, I guess that's good enough. Maybe the fan stopped working, disconnected happened on my Himera. Yeah, usually that's because of this. Heat creep is usually the cooling fan responsible of the cold end that is not working anymore. But in this case, he clearly said that he checked all the fans and they are working well. So I guess it's something else. Okay, next. Again, we are reviewing these questions, but if you have any, we will answer yours as a priority, right? Come out on PLA. Thank you for the explanation. I know that problem from using 3D Max filament jammed every roll of that stuff because of what you described. Yes, and if you have our PLA, you should not have the same issue. Oh no, sorry, that was from someone else. Yeah, okay. Any insight would be appreciated. Well, it looks like warping, right? Let's check. So that's on the Voxel Lab printer, and well, that's it. Any insight would be appreciated, and then a picture. I guess it's a warping issue because you have the skirt here, so the model should always be at the same distance from the skirt everywhere, and here it's way further. So I guess this part should be actually on the bed, so it's warping pretty badly. Lower the bed temperature and use glued stick. Yeah, I mean, he's not saying anything, like not even what material he's using, what is the bed temperature, what is the nozzle temperature. How can you say lower the bed temperature if you don't know the bed temperature? What if he's not using a heated bed? I dislike Reddit in mobile. You can see slightly lifted on the side. I'm thinking it's the leveling, but I'm not entirely sure. Yeah, I mean, there's no way we can help him. He literally just post a picture and ask any insight would be appreciated. Well, what we can say is it seems that you have warping issue. Yeah, that's it. We give an answer as detailed as his question. I don't really know how to answer. I have no idea how to answer that. By the way, for all of you, if you need some help for troubleshoot, believe me, the more detailed your question, the more detailed the answer. That's for sure, because you are helping. You need to help people to understand better what's happening, and then it will be much easier for them to give you a much more accurate answer. I'm late to the party. No, don't worry, you're never late, Santiago. You forgot the question from. Oh yeah, you're right. I said I will answer after. Let me check. Okay, so what was the question? I got an answer on Discord, but curious your opinion. Do different ASA colors have even better UV resistance? I have tomato trellis part going into a greenhouse, and I need all the help they can get. I have no ideas what is tomato trellis part. Whoa, is that the whole structure? I have tomato trellis part going into a greenhouse, and I need all the help they get. Oh, you're going to 3D print, or I guess you're going to 3D print some kind of connection for that structure, something like this, right? Okay. Okay. Let me think. I wouldn't say so. I don't think. I mean, the short answer is yes. The long answer is I don't think. I think it's very negligible, because obviously different formula would have different properties. That's for sure. Because in one ASA you're going to put white pigment, and the other ASA you're going to put black pigment. So they will obviously be different, but the difference is negligible between the different colors. Maybe white could be slightly more UV resistant than other, just because it's white. And in general, all the white polymer are usually more UV resistant because it doesn't absorb as much. It actually reflects, if my theory is correct. So, but I think it's negligible. I don't think it's very important. You are not going to see any difference if you print in black or if you print in white. But if you wanna, like you say, all the need their help, all the help they can get, then maybe white, and then but I don't have data to prove that though. It's just theoretical. um where was I? um by the way, thank you, FDAF Patch, for bringing that up. I completely forgot. I didn't even think about printing connectors for DOs. Yeah, that's usually the issue, right? When you're building something, is how you connect all of these parts together. You either hammer them together with a nail, or glue them together, or you just print connection, and then you just build your stuff. I'm awesome and sleepy. Doesn't carbon black help with UV resistance? Are you using any carbon black in your pigment? Yeah, all the black. That's a good question. Like, you can have two approach. Approach number one is white is basically not absorbing any, is reflecting all the colors, right? And the black is absorbing everything. So my theory is that the black is the one the white is the one that is going to reflect the colors. And I kind of associate colors with UV, which might be a mistake, but UV resist. I mean, we can ask Google, right? UV resistance, white color, black color. Let's try with these keywords. Is white or black more UV resistance? Darker color absorb more UV than lighter colors like whites and pastels. This means UV rays are less likely to reach your skin, but bright colors such as red can also absorb UV. Darker colors absorb more UV than lighter colors. So that's the theory I put forward. Is if you have very light colors, then it will not absorb as much UV. It will reflect the UV, and the fact that it does not absorb it, then maybe it will affect less the chemical structure, right? It will, because the UV is energy that is going to break down the polymer. But if you reflect the UV, then maybe it's not gonna break down the polymer as much. But again, that's just theoretical. I don't have any data to back this up, so I don't know. It's just it's like the heat is the same, right? Black is gonna heat up more than white. Just the fact that the white is going to reflect away the energy, rather than black is going to absorb it. So that's kind of my way of thinking. UV is part of the invisible, blah, blah, blah. Yeah, so that's the thing. UV is not part of the visible light, so I don't know if it works the same. But I can do some more research, or I can ask the real material expert if from our team, to see if they have an answer. Happens to ABS in the sun. Thibon, sorry, I'm not too sure what's your question. Happens to ABS in the sun, or what happened to ABS in the sun? The biggest thing that happened is discoloration. That's the biggest thing that happened. Who in chat thinks printer vibration dampening would be a good printbuster topic? Let's ask this in our printbuster community on Thursday. Looks like that's talking about clothing and skin exposure. Yeah. It's just the logic. I just wanted to see whether the logic was the same. But I can do more research in Sendium. On Voron Discord and NeuroStream, they warn against using white ABS because of additive titanium, which makes white ABS brittle. Thought. I don't know if it makes it brittle, but I know it makes it more rigid. So you have to be careful with the word brittle, because a lot of people think that, what does brittle mean? We have to go back to definition, right? Because would you consider PLA as brittle or not? Because PLA is very rigid, and a lot of people kind of has the misconception between being brittle and being rigid. It's, for them, is the same. If you have something that is much more rigid, then they consider it as brittle. But is carbon fiber brittle, for example, just because it's very rigid? I don't think so. So yes, titanium oxide will make the material. If I think so, will make the material. It's like the FR additive will make the material more rigid. So it will have a higher modulus, and usually a more rigid one will lower its toughness, which means it will have less impact resistance. So you can define whether you associate this with brittle or not. But yeah, so it's like if you have a look at our PCFR, the additive, the FR, will make the material much more rigid. If you check, for example, the tensor strengths, or even if you have a look at the modulus, you can see the modulus of our Polymax PCFR. You see that the FR additive is making the part more rigid, so it's stronger. It's stronger than our Polymax PC, but I do think it's less tough. So let's check. Yeah, and you can see that it loses its toughness. So it's a compromise between being stronger, being more rigid. You can see the Young's modulus, maybe the bending modulus as well. So it resists deformation much more. Whether you call it brittle or not, that's up to you. I just remember the other day, Matt 3DPS got a nice question on the Discord on the Polyflex TPU 90 channel 2 days ago. Tagged you, I think. Yeah. So let me check because I'm a little bit late on my Discord discussions. So let's have a look. So you said on which channel? TPU 90. Okay. So TPU 90. Okay. Let's check that question. Okay. Do you know if there are any tests that are suitable for TPU heat resistance? For example, I'm sure there is a certain point where the material becomes sticky. For me, this would be the failure point. If I had a heat resistance application, perhaps at that point, it's not defined as heat resistant, but maximum operational temperature. That's a good question. I'm not sure. I need to do some research. Actually, you know what? I literally have that discussion on Facebook. Let me quickly open my Facebook, because there is a guy on Facebook that asked this. Let me show you, and I think that's important because when you ask something, you have to think about what you're asking, right? Here's what I saw on Facebook on one of the 3D printing group. Okay, so it's called 3D printing. So that's one of the 3D printing group, 100,000 people. And then the guys was asking, where can I get a high temperature resistant TPU? But you cannot ask this kind of question, right? You have to be more precise. So like basically what I told him is, how do you define heat resistance? And then his reply was something that can withstand up to 150 degrees C. But the same, how do you define withstand? We can go far here, there, right? But so I answer, what does withstand mean? You want your part to withstand a certain amount of stress without bending until 150 degrees, because TPU will bend at room temperature. So he's talking about something that is heat resistant, right? He's gonna, I don't know what he means, but it's gonna hold up until 150 degrees. But TPU, even at room temperature, you put a little bit of stress and then it's completely bending. So what does that mean? A heat resistance of 150 degrees for TPU. So then he say, I have no TPU that deform at room temperature. I'm in the Caribbean. I use TPU up to 50 degrees. I see materials online, but not seeing them to purchase. So he's using TPU up to 50 degrees. What does that mean? Does that mean TPU is completely rigid, and then at 50 degrees suddenly it's flexible? And then I asked, what TPU do you use that has a viscous softening temperature above 50 degrees? And then I explained, I think the challenge is that your question cannot really be answered. You can look at this like this. TPU is already above TG at room temperature. The TG of a regular TPU maybe around -20, -30 degrees, right? So it will be on its rubber state. From there on, it will just get softer and softer and softer. So there is no particular point defined as heat resistance point. If you want a polymer which can withstand stress at high temperature, then why not using polycarbonate? It has a HDT which is close to 150 degree, not our polycarbonate, but regular polycarbonate. So that's the point, and that's exactly the question of Matt. Is like, how can you define a type of heat resistance for a flexible material, which I guess that's what he mean by TPU, right? And that's a good question. I'm not too sure. We can try to do some research on, how in the industry they define heat resistance or operational temperature, because TPU will basically, it will be flexible, and then it will just become more and more flexible. It will become more softer and softer, and at some point it will become so soft that it's like a chewing gum, right? You will be able to take it apart slowly, because it will be the energy will be high enough so that the polymer can separate themselves. So so you get what I mean? The heat resistance has to be defined, and that's why here you have heat deflection temperature at 0.45 megapascal, heat deflection temperature at 1.8 megapascal, and TPU doesn't have this. You see, if I select my TPU, there is no HDT. Why there is no HDT? Because even at room temperature, then they cannot even resist that stress. And that's how we define heat resistance. You have either the Vicat softening temperature, which means the actual softness of the material. At which temperature does it become soft? At which temperature you can push a needle inside, and then the HDT is at which temperature does it start to deform more than a certain amount with a certain amount of stress. So when you ask for whether something is heat resistant or not, then you have to define, what type of heat resistance you are talking about. And then there is all of these questions around creep, right? Creep issues or temperature creep deformation. This is also important to know. Okay, so that was the question from Matt. Santiago, I think like in nature, darker skin is more resistant to UV because the pigment absorb it and prevent it from damaging tissue underneath. Maybe it's the same pigment for plastic. I could be, Santiago. That's the part. It's either the white reflect away the UV so it doesn't affect the part, or the black pigment is absorbing, so the pigment itself is absorbing the UV, so it doesn't affect the backbone of the polymer. So maybe black and white, they are both good, but for different reasons. I don't know. Yeah, definitely makes sense that white could reflect UV. I think I read something a while back about carbon black absorbing UV and keeping it from attacking the polymer chain. Not sure though. Yeah, maybe both. Maybe both are good for UV resistance, but for different reasons. That could be. If it's just discoloration, the tomato shouldn't care. Yeah, Thibon. Yeah, the tomato shouldn't care. Yeah, it's funny to say, but yeah. Incendium. Nero was saying the problem with earlier white ABS was layer adhesion. Yeah, it could be. I mean, different color. So the most important is the color concentration. If the color pigment concentration is too high, it's really going to affect the printability. And one of the things is layer adhesion. Hey, Maker Muse, right? Thank you for joining the stream. Have you already started testing the new PLA for cosplay props? Polymax PLA is super tough. Thank you for the great feedback. Forrest Gibson, I read somewhere Polymaker PTG is PCTG. Is it just similar in properties, or is it actually a PCTG blend? No. So it's not a PCTG. Actually, I wrote something. on Polymax PTG that I'm going to read out to you. Okay, so I wrote this a while ago when we launched this website. So what is the difference between Polymax PTG and PCTG? Okay, which I think is kind of your question. So a little bit of material science first. PET is made of well, I'm not going to read that because my pronunciation is going to scare you away. But TPA and ethylene glycol. Okay, and PCT is made of TPE and CHDM. Okay, so that's a little bit of the background. If you react TPA, which is the main thing for both, with both EG and CHDM, you get a copolymer called PETG or PCTG. Okay, so if you react TPE with EG or CHDM, so that's where the G come from, right? Because you're changing the diol. So usually the polymer is called PETG when the major diol is ethylene glycol, more than 50%, and PCTG when the major diol is CHDM. Okay, so they are both the same, but depending on the amount of the diol, then you are going to call it PCTG or you are going to call it PETG. The higher the ethylene glycol content, the stronger and more rigid the material is. The higher the CHDM content, the more ductile and impact resistance the material is. Okay, so PETG is a more rigid and more strong material. PCTG is going to be a more ductile, a more impact resistance material. So, in summary, PETG strong and rigid, PCTG ductile and impact resistance. Our Polymax PETG is a modified PETG with enhanced fracture toughness, which makes it more ductile and impact resistant. So again, our Polymax PETG is a PETG, but it's a reinforced one with our nano reinforcement technology. It's like tough PLA. Tough PLA is a PLA, but it's reinforced with our nano reinforcement technology. So to conclude, Polymax PETG provide the best of both PETG and PCTG with high strength and rigidity, as well as enhanced ductility and impact strength. And of course, the price. Okay, the price is actually better than a PCTG. So I hope that answer is detailed and complete enough to answer your question, Forrest Gibson. Zombie, what's the most stiff material with heat resistance? Well, it depends on the dry or wet state, but on the dry state is PS6CF. So the most stiff material and heat resistance, though, I would refer to the HDT at 1.8 megapascal. So you can see that PS6CF is the most rigid one. But at a wet state, then it would be PA12CF. So either PS6CF or PA12CF. But in reality, like in a day-to-day use, then it would be PA12CF, because in any case, PS6CF is going to absorb moisture at some point. So to answer you, what's the most stiff material and with heat resistance is PA12CF. However, if you are taking in account creep, so like the heat resistance and stiffness over time, rigidity over time, then I would say polycarbonate. Maybe our PCPBT would be the highest heat resistant and rigid material. Interesting though, Polytera seems to handle solar heat very well, I guess, I hope. Yeah, so actually Polytera, most of you may not know, but Polytera is almost as UV resistant as ASA. We did some tests, and I will share the data on this Power BI if you want. But a lot of people say, yeah, PLA is not heat resistant, UV resistant, blah blah blah. Has any of you ever seen a chart with data that shows the UV resistance of ASA and the UV resistance of different different PLA formula? I don't think there is much out there. And the main reason why people think ASA is heat resistance and PLA is not is because of common knowledge. And you know that at Polymaker, Print Busters, we don't like common knowledge. We like data, right? So that's one thing. That's one thing for you there. Polytera PLA is as UV resistance as Polylight ASA according to some tests that we have done. Like you do an aging test and then you check their mechanical properties and discoloration. Maybe delaminate at temperature. The user doesn't understand TPU. Maybe he understands what TPU is, but I think he doesn't really think too much about when he asks heat resistance. He's like, what's a heat resistant TPU? But he needs to think about what he means by heat resistant TPU. Temperature that would allow it to permanently deform, maybe. Yeah, maybe. I don't know. Where was I? Sorry, my chat jumped. I would assume in this case he means doesn't permanently deform. Maybe. Blah blah. I have heard white needs a lot of pigment. Not necessarily. It depends on the raw material color. So, for example, if your raw materials is more of a yellowish, darker, like grayish, yellowish color, then you may need to put a lot of white pigment to make it white. But no, I haven't heard too much about that idea that the white pigment needs to be in more concentration than other. I can only think something like show harness there's temperature graph or maybe elongation at break there's temperature to have a comparison point to make sense on the metric for TPU and the temperature. Yes, FDAF patch. I think that's the best. You just plot a certain measurement with the temperature, and I think that would be the best to understand the heat resistance of TPU. I have to run it in the dryer. One bag is damaged. Oh, sorry to hear that. Maybe because he went too far in Canada. Do you optimize the materials for ultra high speed printing? What can be optimized? You can. Our Polytera PLA is based on a high speed PLA formula. So if you notice, I think Vice has done some tests, and I still need to put it on the Power BI, but he did the CNC Kitchen test, the flow test with a bunch of our PLA, and you can clearly notice. I mean, actually, you know what? You should be able to see that with our melt index. So if I put all our different PLA, for example, and then I show you the melt index, you can see our Polytera PLA is way higher than the other. And the main reason is because it's based on the high-speed formula. So yes, we can optimize materials for high flow. And you can also, another example is our TPU. If you check our TPU, you can see that our HF, which is a high flow, is also higher than the regular TPU 95. And please note that the yellow one is done at 185 degrees, and the red one is at 210. So the difference is even greater than that. So the answer to Jianja is yes. What can be optimized? But there's a couple of things that can be optimizing the material in order to have a higher melt index. I mean, you can play on the molecular weight. You can play on plasticizer, for example, lower the TG, or you can play on the shear thinning idea. So you can have a material that most of the polymer, the higher the shear stress and the less viscous they are, so they flow better. There's different way. I'm not an expert in that area, but there's different way of making a material high flow. Plus, it's relative to additive. Yes, also. Phil Bolduc, I'm here. PC probably, blah, blah, blah. Okay, I have both of those. I would be sure for a printer mount under the bed. Okay, seriously, Polymax PLA is amazing. I have a project in mind because how tough it is. Great. It's the most. It should be one of the most, if not the most ductile PLA on the market. Polymax PLA. I mean, you can check the impact strengths. You can check Polymax PLA and the rest of the PLA. I mean, there is a word different between Polymax PLA and the rest. Polymax PLA is really one of its kind. I love this data. Where can I find this link? Tor's Fighter. You go on our website, us.polymaker.com, and then you just go material comparison, and then you will be redirected to this interactive chart. Forrest Gibson, great answer. That's good to hear. In most of my application, I need a good balance of rigidity and impact resistance. PETG has historically been a great material, but a tad too stiff to drop. Try Polymax PETG and print it without the fan, and you're going to be impressed. PA12CF is so stiff that it sounds almost metallic when you drop it. Oh, really? I need to experience that. I think you told me that already, but I haven't experienced that. I haven't tried, I mean. I didn't know that Polyterra is UV resistant. You told me, but I didn't know it was that good. I will try to share the data. I haven't prepared them now, but next time I will prepare. I'm thinking of making a bracket that turns my 4-point bed into a 3-point bed, so it would be right up next to a 100-degree heater. Okay. I'm thinking of making a bracket that turns my 4-point bed into a 3-point bed, so it would be right up next to a 100-degree heater. I didn't understand. Sorry, just catching up on the street. Thanks for mentioning our chat about TPU heat resistance. Are you publishing comparison data for a competitor material? Yes, we will. We are working with MyTech Fund on this, but it would be third party, so it won't be tested by us. The competitor materials, it would be tested by third party, and then we will display them. But both our material, you will have access to our TDS, so the one we test ourselves, plus you will have access to competitor data tested by third party and our material tested by third party. So you will have both. Is it my internet is not good enough? Can you guys hear me well? Was it like this since the beginning, or? Yeah, let me know if you cannot hear me very well, because it seems that my internet is only 1 bar. I don't know why. But the rest seems fine. Let me continue. I can hear you just fine. You're good. Okay. Yeah, so it's strange. Usually when it's 1 bar, then it's completely off. Okay, great. Then I will just continue. Where was I? Publishing data, yes. Does PS6CF becomes more stiff after annealing? Yes, it will. It will. The crystallization, the crystallinity degree, the higher it is, the stiffer it will be. But the less impact resistance it will be also. So the higher the crystallinity degree, the less the ductility, the more the rigidity. I'm up to speed on watching live now. Watching Nicholas for 5 minutes at 2 times speed involve intense concentration. That's interesting. Catching up the speed. Yeah. Because I was thinking, how can you catch up the live if I'm live, right? So you will never catch up. But okay, you were watching at 2 times speed. Thank you for answering my question. No problem. Any question you have, please ask. I will answer all of them. Yes, I'm trying my first lithopan with white Polyterra. It's really nice. Yes, I actually talked with Matt German, and so he's very, very experienced with lithopan. And basically, what I learned from him is 3 things. Things number 1, lithopan, a good PLA for lithopan is all about the transparency or the opacity of the material. If it's too translucent, it's not good. If it's too opaque, it's not good. It has to be a middle ground. It seems that the regular PLA are too translucent. So our Polytera PLA are actually more opaque than regular PLA. So maybe that's the reason why a lot of people like Polytera PLA for lithopan. Factor number 2 that I learned from Matt German is the whiteness of the PLA is very important. So you need to have a very good white in order to make good lithopan. So Polytera PLA white is, yes, it is white, but I don't think it's the perfect white. So we could do some work in order to make it even whiter. And the thing number 3 that I learned from him is, it seems that if you are making black and white picture, having a gray PLA is better than the white one. But if you are making colored lithopan, then the white one is better than the gray one. So I did learn a lot of stuff from Matt German. He's going to help us testing some of our material, and we are going to design a special PLA for lithopan. So as most of you know, we are designing a special PLA for props, right? For making cosplay props for movies or cosplay or something. So we have 18 testers. Actually, some of them are in the chat. Like for example, the 3 even is one of our testers, and the main thing was sendability and mechanical properties. So we are designing more and more materials that are more niche. So you have a specific application. We are going to learn about that application, what needs you need, and then we are going to tweak a formula in order to make it good for your application. Is it true that ASA smell less than ABS? Let me think. Acrylonitrile and then the B. No, I don't think so. I think they should smell similar. I don't think it's true. I think it mainly depends on the manufacturer. Like if you are using our ASA or our ABS, it will smell much less than maybe more regular ABS or regular ASA. But between them, I haven't seen so much difference. I do print with both, and yeah, I haven't seen any difference. How does Polymax PLA compare to the new data for Polymax PC? How does Polymax PLA compare to the new data for Polymax PC? I don't know, Matt. I don't have. Oh, I think I have actually, but I haven't checked. I need to check. I guess you are interested in the impact resistance of PC, right? Because the old data, if we put the old data on the graph, then Polymax PC would be here. So I guess your question, is whether with the new data, the Polymax PC would be above Polymax PLA, which certainly is. But I will have to check. I didn't check. But I think it will be. If you test Polymax PC with our 2022 standard, I think it will be above Polymax PLA. Where was I? Cool. So there will be testing by the same lab for some of the data. Good to hear. Where? It will be My Tech Fun, the YouTube channel. So it will be tested by Igor, but I think he has very good standard. I think he has a very good way of testing. So it's reliable. Make of Misra, you need to take a break, Nick, and have a big spoon of that hazelnut spread. But I will drink though. I'm a little bit thirsty. Does ASA smell less than ABS? I think I answered that already. Sophia or Sophie, I don't remember. Are you going to make a CMYK PLA for the new technique of printing multicolor lithopan as shown in the CNC Kitchen new video? I haven't got time to watch it. I'm sorry. Yeah, I haven't got time. So I have no idea what he's doing in that video. I did see the thumbnail. I did see the video, but I haven't watched it. Where's the video? When did he release it already? Is that a long time ago already? Where is that video? The thumbnail is pretty colorful. What? Where is that video? CNC kitchen. CNC kitchen. Yeah, I don't know what he's. Oh yeah, that one. I don't know what he's doing in this video. So it seems like, okay, so he has CMYK, and what is he doing? Okay. Okay. Yeah, okay. Oh, okay, so he's blah blah, okay. Okay. And then he's using the slicers, okay. Oh, that's smart. Okay. Oh, okay. Yeah, no, we haven't yet, but but we could have special CMYK. Actually, you know what? So if we go in our Polylight PLA CMYK, so we are going to have C, we are going to have M, we are going to have Y, we already have K. Oh yeah, I mean, we are already going to have. It's not going to be called CMYK, but it's basically cyan, magenta, yellow, black. So yes, we will have a better yellow. We will have magenta. We will have cyan. So it's going to be a lighter teal, and we already have black. So yes, the answer is yes. What cosplay PLA? I have never heard of it. It's not the perfect gray of anything. By the way, Maker is right. The real product is going to be a lighter gray. So what you receive is a slightly darker than the product we will release if there is a consensus with all our testers that one of the sample is good enough. Polymaker hardly smells. Oh, the ABS and the ASA, yeah. Yeah, the ABS and the ASA smell less, yes. What's up, everyone? Thank you, Everything Plus Ultra, for joining. Yes, impact. Yeah, Matt, I will share it with you after. I haven't looked at it, so it's still in the R&D folder, all the new data. I didn't have much time. A question I have had trouble finding an answer for. If I have PETG that sat out for a while, I'll get poor layer adhesion for the first few layers of it, but fine after. It's most likely because the moisture is, the moisture will be absorbed by the layers outside of your spool. And then maybe on the inside, then it absorbs less than the outside. So maybe you have moisture issue at the beginning, but the time you finish the first layers of filaments, then maybe it's getting better and better. It's like when you're drying. When you're drying, then the outer shell of your spool is dried properly, but maybe the core, the filament at the core, but then they are dry less. So it could be one of the explanation. I need some purple and magenta soon. Purple is already there. Here's the purple, and we are going to so this number of colors. So that's 11 colors, right? We are going to more than double that in less than 3 weeks. So think about all the colors that we could release. I think we are going to have, maybe not almost as much as Polyterra. I mean, Polyterra, how beautiful it is when we have everything in stock, right? You can see all the colors, nothing is out of stock. How beautiful is that? Because believe me, it's hard to keep more than 300 SKU in stock. Great. I printed some lithopan, and my favorite color is a real crisp white. I don't know what it means, but I guess a very, very white. Beatles cover. I asked because so that means you asked something before, right? What was the does ASA smell? Okay. I asked because I use the material for twisty puzzles, and I'm thinking about trying ASA for them because I require strength, impact resistance, and temperature stability with the ease of polishing. Okay, you would have stopped at impact resistance, then I would have recommended some other PLA. But if you also need temperature resistance and ease of polishing, then yeah, I guess ABS is a good way to go. ABS or ASA. So can we expect the full CMYK-B or CMYK-W coverage? It would be nice to know if I ever want to make a printer with that rip-wrap diamond nozzle. That thing is madness, and I love it. Yeah, I really like that idea because it allows us, if it's really working, then we wouldn't need to release that many colors. But I guess your meaning is CMYKW, right? So cyan, magenta, yellow, white, black, and white. Material is generally kept around 30% relative humidity or less, and the print otherwise looks fine and not moisture issue. But I don't know what else could it be. Any thought? Okay, so you were saying if you leave the PETG spool for a while and then you print with it, then you have some layer adhesion issue at the beginning and not after, and it's not related to moisture. I can pour layer adhesion for the first few layers, and you print fine after that. Yeah, then I'm not sure if that's not related to the filament itself. Pour layer adhesion at the beginning. So does that happen with a new spool as well? Like, let's say you just dry a spool. Yeah, maybe here's the question. If you dry a spool, do you have the same issue? Because if you have the same issue, whether you dry the spool or whether you don't dry the spool, then it means it's related to something, maybe your setting or maybe the printer or something like this. If it's if you dry the spool, then you don't have that issue, then it is related to something that is happening to the spool when you leave it for a while. Yes, Hydro Homie. I have heard that carbon fiber ABS doesn't really make it. My chats. I have heard that carbon fiber ABS doesn't really make it stiffer, but some said glass fiber work. Do you know anything of this? I don't know. Carbon fiber definitely will make the ABS stiffer. I don't think there is any question about it. However, maybe what you have seen is that carbon fiber will make the overall ABS part weaker in a way that it will have less strength, less layer adhesion. So maybe that could be the case. And glass fiber works. Well, glass fiber will have the same issue. If carbon fiber has issue, then glass fiber will have similar issues. Yeah, so no, I don't know anything about this. Carbon fiber will definitely make the ABS stiffer, and glass fiber also, but glass fiber will make it less stiff for the same percentage. So if you put 20% carbon fiber by weight in ABS, it will be stiffer than if you put 20% glass fiber by weight in ABS. I'm almost certain about it. Those colors litho are super nice. Yes, I agree. Are there any other additive besides carbon fiber that help with surface finish but don't negatively affect ductility? I love the look of CF part, but usually don't want increased rigidity. Yeah, there's many. I mean, look at our Polytera. Polytera PLA has that matte finish, or even Polytera PLA Plus, a satin finish. So there's many ways of making a special finish. But if you want that carbon fiber finish, then you need carbon fiber. But if you want like a matte finish, I mean, you can check out. I don't know if Loyal is still streaming, but he printed two helmets. One helmet in carbon fiber PLA, one helmet in Polytera PLA charcoal black, and the two helmets are very similar. So
nozzle temp right.
So if you check just behind him, I think is well, we wouldn't tell the difference, but just behind him there is a helmet. You can go on his stream. You can tell him you come from the Polymaker stream, and then you want to have a look at this one. You can tell him I'm sending you there, and then he's going to show you both carbon fiber and the charcoal black, and it's very similar. It's very similar, and the Polytera PLA additive makes the material more ductile. So if that's what you're looking for. Oh, sorry, I was not sharing my screen. There you go. So behind him here, there is the helmet just behind. Let me put back. Let me put back on the screen. CMYK pack. Yeah, we could have so CMYK pack. Magenta. Yeah, we will have magenta. So the sample 1 will look like sample 2. Oh, you mean maybe I haven't seen the final shade of gray we are going to use, but it's going to be lighter. Cell CMY pack. K is white, and that's common. Oh, K is white. I thought K was black. Really? CMYK. What is K? The K in CMYK actually stands for key, as in key color in key plate. And yes, black ink is typically used as the K, the key. Yeah. So usually the K is black, right? Not white. But anyway, there is no rule. K can be black and white. But for me, it's typically black, not white. So that's why I was asking. But anyway, in 3D printing, I guess you will need two keys, one black and one white. Can we get platonic blue glow PLA? What's platonic blue? Is that like a boring blue? Platonic blue. So like a light blue. Is that a platonic blue? How about the glow in the dark blue you have? Is that platonic enough? Glow PLA blue. Yeah, it's pretty much the same, right? That's platonic blue, no? Oh, we are out of stock of both. I mean, the blue is out of stock. This is normal because we need to redo the pilot test. But the green, I don't know. Maybe because of the deal. But yeah, it looks like a platonic blue to me, or at least platonic blue according to Google Image. White is not a color, lots of variation, plus you would want the same material. I missed where you answer my ASA question. The parts I'm printing are clips that attach tomato stems to string. Dinner with the family. I was answering that that is negligible. You can use any colors. It's going to be as UV resistant than as the other colors. So that's the short answer. If you're listening, not sharing your screen. Oh yeah, I'm not sharing my screen again. That's why I usually always share my screen, but when I'm answering there, then I want to share. Yeah, sorry. So that's what I was showing off. For me, that's platonic blue, and apparently, according to Google, platonic blue means this. This is platonic blue. So for me, so it's literally the same color for me. So I guess we already have a platonic blue glow in the dark. Um, that's what I was thinking, but didn't find info on people getting layer adhesion problem with moisture. I was seeing people talk more about extrusion and surface finish problem. Yeah, I mean, it has to be something with the material. If, like I said, if you dry it and you don't have the issue, then it has to be something with the material. Yeah. Slow down on releasing new colors. My wallet can handle it. Epoxy jewelry. I think that's an Etsy store, no? If I remember well. You contacted us for the Etsy discount. I did tell you, Polymaker, I picked up some PVB polysmooth. Oh, cool! Some smooth project on the on the horizon. I meant it could be moisture. It just doesn't look like the classic moisture bubbling that I've seen elsewhere. Yeah, I mean, sometimes moisture issue are just related to mechanical properties, but it's not as severe. Usually, bubbles is the most severe thing that you can have from moisture. So maybe sometime, but I mean, a very quick way to confirm that is, you take the spool, you print, you have the layer adhesion issue at the beginning, and not after, and then you print another one straight after, and then you check if the beginning is also wrong. If the beginning is also having layer adhesion but not after, then it's definitely something related to your printer or the setting, not the material. Sometimes the outer layer is state. Sometimes the outer layer is stale. I don't have a great drying setup yet. It's something I need to work on. Yeah, so I have another test for you. Just print one, and then at the beginning you will have some layer issue and not after, and then print another one straight after and see if you have the same issue. If you don't have the issue, then it's definitely related to the filament. If you have the issue, then it's related to printer or setting. The CFPLA is super light, and I found it very robust. Yeah, it is lighter, I think. Let me check. If you check the density, where's my density? Density. Oh, we don't have the density of CF. Oh, sorry, we don't have. But I guess, yeah, I guess it's lighter. But it was not meant. So our PLA carbon fiber was not meant for mechanical properties. It was just meant for a nice finish. Polytera makes good planters and bird baths. Nice. Loyals is waiting for focus to be done. Okay, still not sharing your screen. Yeah. Loyal will be back live shortly. Okay. The gray shade you just mentioned. I know there's a ton of PLA option for surface finish, but seems CF is among the only variant of higher temperature material. Is it because PLA is more popular? I know there's a ton of PLA option for surface finish, but it seems CF is among the only variant of higher temperature material. Oh, okay. Yeah, I think it's because PLA is more popular. There is rarely a filament manufacturer that is going to put effort in making fancy nylon PC or this kind of thing. So we could make a matte PC, matte ABS, matte nylon, but it's just not worth it. The market is not that big. ABS and ASA, yes. We are working on a few fancy version of ABS and ASA because it was asked a lot by 3D printer community, like especially the Voron community. So we are working on that, but other high temp material less. K is key, yes. It's solid blue, but it's glow in the dark. There is green version. There's like fluorescent, yes, but it's white, but glow blues. Oh, you mean it's blue and it glow blue. Oh, okay. There's a green version. There's like it's very hard to make a color that glows colored, because if you have a colored PLA, then it means it's an opaque filament. So the glow will only be on the surface. So it won't glow basically. It either won't glow at all, or it will glow very less. It's like you can think about like sparkles. If you put sparkle in opaque filament, then you're only going to see the sparkle that are on the surface. You are not going to see it inside. But if you have a translucent PLA with sparkle and glitters, then you're going to see all of them. So the glow is a little bit the same principle. So that's why we usually use natural, because the natural is the light can go through better. The glow in the dark blue is super solid. Is super sold out. I've been waiting. Yeah, that's because of we are doing the pilot test again. Thank guys. See you. I gotta go. Okay, see you, Santiago. Thank you for coming. When is that glow in the dark blue going to be back in stock? Hopefully by September. Incendium, thanks. I look more into drying setup. Does your CF filament use chopped or milled fiber? Chopped fibers. Only on the market, I think only the ESD are using milled fibers. I think all the carbon fiber are using chopped fibers. I think. Yes, another print is okay. So it is something about the beginning length of filament. Oh, okay. Yeah. Yes. So I guess moisture or aging in general, which involve moisture, UV degradation, or this kind of thing. Sparkle ASA, please. Yes, we know. I have used PLA-CF for looks and mechanical value, and it's good at both. I will be using Polymaker PLA for the machine part from now on. Okay, good to know. Hopefully matte PC happens eventually. That would be my new daily. Maybe 3D printing grows, there will be a market. Maybe at some point. I'm building some, you see, we only have black and white. We just released gray, red, and blue PC just because not much people use other colors than black and white. So you can think about matte colors, even less. I'm building some custom 3D printers and need fun ASA colors. Yes, it has been required so much. Yes, they both fluorescent green and blue, and it takes more light and time to charge it to glow. Okay. Are we going to get the new dark green glitter soon? The blue is so good. You mean the Sparkle or the Galaxy? Because the Galaxy series is already available. And it should be, well, except the black, but the blue and dark red are in stock. The black will be in stock soon, I guess. Daily reminder that Galaxy Blue is out of this world. Yeah, this one. I think Zombie really like this this blue. And again, I have seen some stream that were saying there is different glitter color. So let me tell you what actually happening. So if you can see, if you zoom, you have blue glitters and white glitters, etc. Actually, the glitters are all the same color. They are all aluminum flake. Aluminum color flake, right? But depending on how deep they are in the filament, then they will appear blue, because you will have the flake, and then on top of that, you will have a little bit of PLA, blue PLA. So the flake is going to appear blue. So I want to clarify this, because I've seen a lot of live stream showing off our Galaxy Blue, and then they say there is different color glitter. So yes, it appears that there is different color glitter, but I just want to highlight that, it's not different color glitter. It's the same glitter everywhere, but depending on the depth in the filament, then they will have different color. That's the idea. The new thing at Voron is Sparkle ABS build. Yes, I've seen that. The Voron team was the one that pushed us the most to get some Galaxy and Sparkle ABS ASA. Different glitter chunk size. Yeah, depending on what your nozzle can handle. Polymaker, are you thinking about releasing master spool refills? Yes, John Strand, before the end of the year. I love the different colored glitter. Yeah, like I said, is not different color, but it's just different depth. But we do have ideas of trying if we could put some actual different glitters. It's how the color is being filtered. Yeah, that really is not blue. It's purple. Is that purple or is that blue? It looks blue to me, no? More blue than purple. But I do agree that this one looks more brown than red. But yeah. Oh, wait, you need a hardened nozzle for that? No, I don't think so. If you check the hardness of the glitters compared to the hardness of brass, I don't think you need a hardened nozzle. When I say what the nozzle can handle, it's a term of the size of the glitters. So if you're printing in a 0.4 and you have 0.4 glitters, then it's a bad idea. No problem, John Strand. Any question, just let me know. I really need that Galaxy PLA to add to my collection. Yeah, go ahead. I don't know if it's if there is a deal on it yet on Amazon, but yeah, go ahead. We will have more colors arriving on our Galaxy collection. Can you make the red actually red? A bright red, yeah. But usually Galaxy goes very well with deep colors, dark colors. So if you check like this kind of prints, I don't know if the Galaxy series would go well with bright colors, but we could try. Or the blue Galaxy is very purple. It's purple, yeah. If any mark wins tonight, I call Fixlo. Don't care what you call it, purple or blue, it looks great. Yeah, I mean, usually whatever color name we are going to use, there will always some people that will see it a different color. It's very hard to name colors, actually. I mean, there's so many. I mean, and also depending on the culture. I mean, this is brown, 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 but some people are going to call it. Some people can consider this orange, for example, or like I don't know. This is green, 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 yellow, yellow, red, red, red. I mean, think about it. This is green. This is green. This is green. In our culture, this is how we call green, but they're completely different colors, right? But there's a nice video, by the way, on YouTube. You can check color, name, culture, and then you can learn. Yeah, this video from Vox, and then you can learn the color name depending on the culture. So depending on where you grew up, then you will see color differences differently. Like, for example, maybe this and this, we call it red and pink, but different color will have the same name for both because they have grew up like this. They don't see any difference between these two colors. But I mean, in the video explained that much better than I do. Lol, Polymaker say it's fine to buy their filament. Yeah, I guess so. I have a slime green glitter from Jesse. It's nice. Okay, good to know that we can have Galaxy bright colors. Yeah, we can try. Only color I need for my maker coin is dark green. Most greens are too light. Really? But I mean, this is a pretty dark green, no? I mean, can you go darker than this? Darker than this green? I'm on clog number 3 with this Motherhacker Pro Ecto Green PLA. Not impressed whatsoever so far. Thought I'd give it a shot since they're having a sale and it's really expensive stuff. Yeah, I don't know what is Motherhacker Pro Ecto Green PLA, but I guess is there some kind of glitter as well? It depends. When we make our glitters, we have high quality control on the size of the glitters to avoid this clogging issue, but we still recommend to use 0.6 nozzle just in case. You can see here on this image, we still recommend to use a 0.6. Silk glitter. Oh, silk glitter. Yeah, could be interesting. According to the internet, must be correct. The hex color code for Galaxy Red should be 45.88% red. The other colors in it are smaller amounts, so maybe it is the name correctly after all. Mark UFU, in terms of the color we put inside, it is red. We put red inside. We put a certain concentration of red. So, that's why we call it a dark red, because it's like a mix between red and it's a shade of red. But I mean, when you think about it, like a red shade, I mean, all of these are called red, but the brick one, I mean, can also be called brown. Here is different shade of gray on red, but this rust, it can be called brown. So that's why color name, it's not really important. We don't really care about color name. It's just some kind of reference. But at the end of the day, the color you see is whatever you name it, but it's what you see that is the most important. I have a Sunlu grass green. That's nice. There's a deeper green than the army green. Army green is not the proper color. Look at my icon. Okay. We do have a bunch of new green that are coming, so hopefully there's one of them that is suitable. Polymaker, I'll email what my logo is maybe company can match the color. For depending on whether you can match the we do color matching, but it's usually around 300 kg order. So if you can order 300 kilogram of material, then we can definitely match your color. Okay, so it's already been 2 hours that we are answering questions, and you guys had a lot of questions today. We only had time to do three Reddit question, but it's good. Most important is your guy question. Oh, Maker's Minute, right? I think you're waiting for a logo. I think the Printbuster logo, right? Not the Polymaker logo. Phil Bolduc is trying to trick the giveaway by doing I'm here all the time. Okay, guys. I will send it to you after Maker Minute, right? Was it the Polymaker logo or the Printbuster logo? Yes, the Printbuster. Okay, I will send you the Printbuster right after. Send him all the logos. Yeah, I will send it to you. Okay, guys. So we have 33 viewers, 42 entries. So I guess everyone is there. Thank you, everyone, for all your questions. Make sure you always record the question you have about 3D printing. Think about anything, and then wait for the Tuesday to ask everything. You just write everything. Write everything in the chat. All your questions one by one, and then we'll go through. 300 kg, that's like 2 years or less product. Well, depending on who, right? Some of our customers, they go for 300 kg in, I don't know, 2 or 3 days, maybe? Oh, no, much less. No, less than 1 day, actually. Okay, great. I guess ready for a giveaway for today to close the stream. Actually, are we still live on Twitter? Is there anyone watching from Twitter? Because I only see YouTube comments. I don't think I've seen any Facebook comment or any Twitter comment. So I don't know if it's worth I mean, we'll continue do a little bit more on Facebook. No, yeah, looks like there's no much. Let me check. Yeah, there's no comment at all on Facebook, and no on Twitter. Only 2 viewers on Twitter. Most of you are on YouTube. So watching on YouTube mobile, yeah. Yeah, I will do a little bit more marketing on Facebook because I know that there should be more people, more people on Facebook that would be interested in what we're doing, like some kind of Q&A together. Okay, guys, ready? In 5, 3, 4, 2, 1. Drawing. I'm sure it's gonna be Phil Bolduc that is going to win today. Phil Bolduc is going to win today. Congratulations to Brian Farmer. Brian Farmer. I haven't seen much message from him, so I'm not sure if he's still there. Brian Farmer, you have exactly 10 seconds to show you are still there. 10, 9, 8, 7, 6. Yes, you're here. Congratulations, Brian Farmer, for winning Polymaker spool. And then you can send me an email there. I don't think I have any comment there. But you can send me there. There you go. Congratulations, Brian Farmer again for winning that spool, and thank you very much for joining the Polymaker stream. So, guys, I think it was very fun today. Thank you for all the questions you had. Make sure that you record all the next question you are going to have in the next 7 days, and then you can ask them in our next stream. So I will see you guys either on Thursday for another episode of Print Busters, so a very scientific live stream on 3D printing, or I will see you on Twitch on Saturday to learn about 3D printing in general, really going back to the basis, especially on the hardware side. And otherwise, I will see you on the same stream next week for another Q&A. Thank you again, everyone, for joining today, and have a good one, everyone. And everyone, homework is to buy Galaxy Blue and post your make on the Discord. Phil Bolduc, 再见, 再见. Thank you for typing in Chinese. See you guys. Bye.